Hello everyone, my name is Rabia Tariq and today I will be presenting my research on predicting carbon emission from vehicle and their driving condition in New Zealand using NZTA data from 2009 to 2025. This research is a part of Data Analytics and Intelligence project. Vehicles are vital to modern life, but their environmental footprint is significant. Globally, the transport sector contributes approximately 24% of carbon emission. Here in New Zealand, our challenge is accurate. 85% of light vehicles still run on diesel and petrol, despite readily available low-emission alternatives. This is heavy releases directly impact our nation ambition goal of achieving net zero carbon emission by 2050. Our central research question is how do vehicle powertrains and their driving condition influence carbon dioxide emission? What are the projected future trends in carbon emission from vehicle New Zealand? The ultimate purpose is to provide data-driven insight that can help lower emission by 2050. For this study, I utilized comprehensive data from NZTA covering 2005 to 2025 with over 2.4 million observations. Let's look at the initial insight from our descriptive analysis. The descriptive statistics clearly show the vast difference in CO₂ emission by vehicle type. As expected, electrical vehicle emits zero carbon emission. Diesel cars have the highest average emission at around 248 grams per kilometer, followed by the petrol car at 229 kilometers. Hybrid vehicles are significant improvement with 103 gram kilometers. This immediately highlights the environmental benefit of transitioning to lower emission vehicles. Our correlation analysis visualized in the heat map revealed a very strong positive correlation between CO₂ emission and fuel consumption. R is 0.99. This is crucial finding. It confirmed that type of fuel and the amount consumed are primarily drivers of emission. Interestingly, speed showed a small negative correlation. R negative 0.17 suggests that steady driving might slightly reduce emission. Road slope and temperature, however, had minimal impact. These findings underscore the critical importance of vehicle type and fuel efficiency in any emission reduction strategy. To predict carbon emission based on multiple factors, we developed a multiple linear regression model after applying a log transformation to CO₂ variable. Our model achieved an impressive adjusted R-square of 99.98%, indicated that it explained almost all the variance in log transformed. Looking at the coefficient, the impact of vehicle category is clear. Electric cars have a substantial negative coefficient of 4.6, meaning they drastically reduce CO₂ compared to baseline. Hybrid cars also show a significant impact of 0.4. Petrol cars have a smaller negative coefficient 0.1 compared to diesel. Crucially, fuel consumption has a statistically significant positive coefficient 0.09, confirming that increased fuel use directly lead to higher emission. Our VIF analysis confirmed no significant multicollinearity, ensuring reliable coefficient estimates. This model strongly supports the idea that replacing diesel vehicles with electric alternatives could lead to significant CO₂ reduction and that managing fuel consumption is the best. To further validate the difference in emission across vehicle types, we conduct a ANOVA test. The results were highly significant, P less than 0.01, confirming that mean CO₂ emission indeed vary significantly based on vehicle category. The post-hoc HSD test provided specific comparison. Hybrid emits approximately 145 gram kilometer less CO₂ than diesel car. petrol emits about 190.5 less CO₂ than diesel car, and petrol car emits significantly more CO₂ than hybrid car, about 125 gram-kilometers. These findings providing strong statistical evidence for benefit of transitioning to lower emission vehicles. Looking at ARIMA forecast 2026 to 2035, the blue line shows predicted CO₂ emission with shaded area of 80% to 95% confidence. We project a brief drop around 2027, but the emissions are expected to rise again until 2035. With the future MAPE, 74.5% indicate current action are not enough. We need more strategies for stronger EV incentives, lower road tax, price reduction for lower emission vehicle, stricter fuel usage regulation to meet our climate goal. Here, it's clearly visible that in year 2027 there is a dip and the rising trend continues till 2037, reflecting diesel dominance and slower EV adoption in vehicles. Our ARIMA model residuals are random, show no autocorrelation and are normal distributed, confirming its statistical soundness for forecasting. Our ARIMAX model incorporating fuel consumption also forecasts increasing CO₂. If measures are not taken, this highlights the urgent need for decisive action like stronger EV incentives, better public transport, and stricter fuel usage rules to meet our climate goals. Our study confirms that electric and hybrid vehicles produce less CO₂ than petrol and diesel cars. The fuel consumption is the most significant predictor of emission. The ARIMAX model provides more detailed insight into future emission trends, underscoring the critical need of strong government policies. These policies should focus on accelerating EV adoption through incentives, reduce road taxes for EVs, and improve public transport to accelerate New Zealand's journey towards net zero emission by 2050. Thank you for watching my video.